Now to find my max and min, I need to solve where the derivative is equal to 0. Okay, so basically I'm going to solve the quadratic equation in the numerator. I'm not going to worry about the denominator. I just need to make sure that that's a restricted value, that I don't, if my x equals that restricted value, then I know that there's something fishy going on here. In fact, there would be a common factor here. So just make sure that we watch that denominator. But I'm going to solve for x. So x is equal to 24 minus 24 squared minus 4 times a times c, and that's all over 2a, so 6. When I work that all out, so that's going to be plus minus, that should be 840 over 6. There's a common factor of 4 here, which factors out to be 2, so this should end up being 12 plus minus 210 over 3. And that's approximately equal to, the decimal values are going to be, looks like negative 0.83, and the positive version of that is going to be 8.83. Okay, so then when I want to show this on my number line, I know that the 0.83 is actually going to be between the 2/3, negative 2/3 and 1. Okay, so this is going to be 12 minus root 210 over 3. Okay, and so we're going to have a 0 slope here. That's going to be this point up here. Maybe I'll do this in a different color just so that you can see we're using the derivative now. There's going to be a point there. Okay, that's going to be that coordinate. We can test our derivative. Actually, sorry, I'll just find the other point here. This is going to be another one here over at 8, 8.83, okay, or 12 plus square root 210. You're going to have another point there, and that's going to be some minimum somewhere around here. Okay, so that's going to be that minimum here. This is going to be 12 plus root 210 over 3, and that coordinate here is going to be 12 minus root 210 over 3. Okay, so there it is. There's going to be my graph. It's going to look something like that. It's going to follow the asymptotes here. Okay, I should show my slope charts. I can do a slope check. So if I do f prime of, I want to choose some number, maybe -1. If I plug my -1 into here, I get 3 plus, what's that going to be? 3 plus 24 minus 22. That's positive. So there's my positive slope, 0 slope, and we can see that, yeah, that's positive 0. If I plug in my slope at 0, it's going to be negative. So I know it's going to be there. I know I have an undefined slope at -4. So I'm going to check the f prime at 5. When I plug 5 into here, I'm going to end up with positive values. So I'm going to end up with a positive slope. Okay, again, I'm just checking this because I know my numerator is always positive. I'm not testing for the value. I'm just testing for positive or negative. So it's going to go up here, across, and then check the slope on the other side of that, this number here, which was 8.83. And if I plug in 9 into here, I'm going to end up with a negative slope. Okay. Oh, sorry, this is going to be negative here. This was negative here. This was going to end up being positive here. Okay, so it ended up being a negative slope and a positive slope. Okay, so it's going to look like this, and that will look like a minimum point. If I look back on my graph, yeah, that point there was a minimum point right there. Okay, so this is the extra part that involves calculus, the derivative, finding where the derivative equals 0, finding slopes, doing a slope chart, testing some slope regions.